Okay, hi guys. So I got a question. I'm gonna go ahead and post the answer to everybody because apparently the video didn't load right into Blackboard. But where? This is my question. Companies who design furniture for elementary school classrooms, measurements and sizes. So okay, here's part of the matter. Suppose the heights of kindergarten children can be described by a normal model. So we have the bell curve. We have a mean of 39.2 and a standard deviation of 1.9. So let me write all that down here. So we have this situation, and he is normal of 39.2 and a standard deviation of 1.9. Okay, and I want to know what fraction of the population is going to be less than 37 inches tall. Okay, so I have a normal model here. Right here in the middle is my 39.2, and I want to be, I think it says less than 37 inches tall. So I guess I'm going to have over here is 37, and I'm shading this side of the line. Okay. So the first thing I got to do is convert this thing right here into a z-score. Okay, so I'm just going to make this a little bit smaller. Pull back up my Word document. So as a z-score, right, he's x minus mu divided by sigma. Sigma, yeah. All right, so there's my x is my data, my 37. 39.2 is my mean. 1.9 is my standard deviation. So what we have is 37 minus 39.2 divided by 1.9. And what exactly is that? 37 minus 39.2 divided by 1.9. So negative 1.16. All right. So that's what this guy is right here. So the question, right, the fraction, the percentage is this area right here to the left of negative 1.6, right? He says less than, that's why I go to the left, right, because less. Okay, so on the calculator, how we're going to do that is I use that z-score. So everything lives in the distribution right here, which is right above bars. So I pick second bars. I'm trying to find the area, so that's the cumulative distribution. So I hit 2 here. And I want to go from left to right. Now again, this thing has to go left to right, so it doesn't necessarily do less than. So all I do is I just pick a value way out here, like 9, and I'm going to go from negative 9. From negative 9 to negative 1.16. So that's what I do. Negative 9 to negative 1.16. Oh, and by the way, I've seen a few times too, it has to use this for the negative sign, not the minus. That'll give you a syntax error. But there you go. Get my answer. 0.123. All right, but I just got to change this guy to a percent. So I guess that's my answer, 12.3%. Good. All right. Okay, in a second I'll make another one for a different problem where you have to go backwards the other way. Oh, I guess maybe I should say this one. Right? Okay, so my middle 60%. Okay, so now I have to go between two values, but they're expected to be between this inches and this inches, right? Now notice they didn't give you a percent, right? I'm trying to get the actual data cutoff points. Here I wanted a percent, which means I use this normal CDF. Now I want to go backwards the other way. All right, so they say middle 60%. Kind of start over. All right, so, all right, let me just make a line here. So the middle 60% is going to cut off there and there. So I have 0.6 in the middle, which means I've got 40 left on the sides. So I've got 0.2 here and 0.2 here. Right, so 20, 80, 100%. That's a decimal. All right, so to get this z-score right here, we use the other function, the inverse norm. It's always area to the left. Okay, so I go up my guy. I put, clear this out. I go into distribution. I need the inverse norm now, right? Because they're giving me the percent and I want the data. So there's 3. If I put in 0.2,